Hello, everyone. It's a very good afternoon, dear authors and invited guests. My name is Richa, and I'm the moderator of this session. If you have any query and any updates, kindly write it down to chat box. And on the behalf of a Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 6th International Conference on Information and Communication Technology for Intelligence System. And further, as we all are well aware to facing a new normal situation while overcoming the pandemic, hence we are shifted our conference to a hybrid mode. So we hope you will enjoy the knowledgeful and interactive session through the day. And we also hope have you next time in physical mode. And just before we get started, I would like to just an announcement for a presenter. There will be 10 minutes for presentation and 2 minutes for question answer. So after 7 to 8 minutes, I will raise a gentle reminder to conclude the presentation. And I'll request while the presentation is going on, kindly the participant kindly be muted. And there's another request to all the presenters, all the participants, you all stay connected with the end of the session. And just before we get started, I would like to introduce our chair of the session, Geeta Nawale ma'am. She's a Dr. Geeta Nawal is working as a professor and head of department computer engineering in Singhar University of Technology and Science, Pune, Maharashtra. She has teaching experiences 23 years and research domain includes knowledge hiding, international journal publications, 30 plus international journal publications, and she attends 20 plus national conference. Welcome to you, ma'am.
Yes, thank you. Thank you so much.
And now I would like to start with papers. Now I would like to call our first presenter, Pawan Kumar, to present his paper on review of different ML techniques using of heart disease prediction.
My screen is visible?
Yes, your screen is visible.
Good afternoon to everyone. Myself, Pawan Kumar from Punjab University. My topic is a review of different ML techniques that were used for heart disease prediction. First of all, what is heart disease? Heart is a very important organ of our body. It pumps blood and regulates blood flow to every organ of human body. Any interruption in the heart's regular functioning is heart disease. And if it doesn't work, the human will die within a few seconds. Scientists have divided heart disease into two elements. First is a risk factor that cannot be adjusted, like family history or gender or age, and the risk factor that can be adjusted, like cholesterol, blood pressure, smoking, etc. These are the symptoms of heart attack: chest pain and discomfort, fatigue or shortness of breath, irregular heartbeat, and cold sweat and unsteadiness. So what is machine learning? Machine learning is a branch of computer science that enables computers to learn without being explicitly programmed. It creates a model by training machine learning algorithms with the training data. The model predicts the heart disease using the new input data, and we can test the model with the test data. And machine learning techniques are divided into mainly three categories. First is supervised learning. In supervised learning, we train the machine using supervised data, or we can say we can supervise the data. And next, unsupervised learning. In unsupervised learning, we train a model using unlabeled data. The aim of unsupervised learning is to find the structure and pattern of input data, and clustering and association are the examples of unsupervised class.
Sorry to interrupt. Your slide is not moving. Please check.
And the last is reinforcement learning. In reinforcement learning, the agent learn automatically using feedback. For example, chess game. So in machine learning model, we use these steps. First of in diagram, we have that first we have data set. First step is the pre-processing of data. In pre-processing, we can clean or clean the data set or remove some noisy data by many steps. Then we have feature extraction. In our process, we use mainly important feature that were relevant to our data set. So we use feature extraction. Then we apply these classification uh, techniques and find out the results. These are the literature review. First, Javin Patel uh, proposed a research in which number of decision tree algorithm compare in terms of
Sorry
performance.
to interrupt. Dear presenter, your slides is not moving. You are on your first slide. Please check.
From my end, slide is moving. Is it moving now?
It's first slide only.
Yes, it's first slide.
And from my end, it's now is it moving?
No, no.
Okay, reshare. Stop. Ma'am, now is it moving?
Still it is first slide.
Ma'am, from my end, it is moving.
I think presenter had shared the minimized screen but accessing on the full screen. So you have to give the presentation view on full screen. After that, it will move.
Now is it moving?
Yes, now it is moving. Please.
Yes.
So in literature review, Jamin Patel proposed a research in which number of decision tree algorithm compares in terms of performance, and the research author found that J48 has the highest accuracy over the logistic model and the random forest algorithm. For the implementation, he used Veka tool, and UCID repository dataset is used. In another, Ashok Kumar Dwivedi compared 6 ML algorithm, logistic regression, SVM, KNN classification, ANN base to find out which one is best for prediction for the heart disease, and the author find that the LR has the highest classification accuracy. Then Anida Khetty proposed a research to create heart disease prediction model with different classification algorithm, based decision tree and bagging. And he found that KNN is gives the best accuracy. Same UCI dataset is used, and Wake a tool for implementation. And Yashwardhan Keshing developed a heart disease prediction model using random forest. And when it compared with the linear regression, logistic regression, SVM decision tree, it was found that random forest give maximum accuracy. Then Aditi Gavane proposed the heart disease prediction system using multi-layer perceptron data is taken from same heart UCI, and PyCharm is used for implementation. Then Santil Kumar Mohan suggested a hybrid HRFLM technique that were made from random forest and linear method. And a Cleveland dataset is used for implementation using RStudio Kettle. Then Fahad Salim created a ML-based model by integrating a 5 ML algo, decision tree, logistic regression, random forest, naive Bayes, and SVM. It gives good result in comparison with previous research Cleveland dataset are used for implementation. And then Devensha introduced a model which use Cleveland dataset of UCI and applied naive-based decision tree, KNN, and random forest. KNN gives the final good results. And second last, Archana Singh ETL implemented different machine learning, decision tree, linear regression, and SVM to solve the problem. And they found the KNN is the best, and dataset is taken from UCI. And Harshit Jindal create a model to detect heart disease, logistic regression, random forest. KNN are used to create a model. KNN gives the highest accuracy. UCI dataset is used and implemented in Python using the Jupyter notebook. So these were the parameters that were used in these papers. First, confusion matrix. Confusion matrix is a summary of prediction results on the classification problem. The number of incorrect and correct prediction are summarized with a count: true positive, true negative, false positive, and false negative are the parameter of confusion matrix. So true positive is an outcome where the model correctly predicts the positive class. Similarly, true negative is an outcome where the model correctly predicts negative class. False positive is an outcome where the model incorrectly predicts the positive class, and a false negative is an outcome where the model incorrectly predicts the negative class. So these are the formulas of these parameters. First, precision. Precision in simple terms means what percent of positive predictions made were correct. So precision is basically true positive divided by true positive plus false positive. Recall. Recall in simple terms means what percent of actual positive values were correctly classified by classifier. Recall is true positive divided by true positive plus false negative. And accuracy is measured as ratio of correctly predicted sample to total sample. So accuracy is true positive plus false negative divided by true positive plus false positive plus true negative and false negative and last one F1 score, which is a harmonic mean of precision and recall. So in conclusion, so as we know, in today's fast-paced environment, heart disease is a major concern. This paper can help the researchers in selecting particular prediction algorithm on the basis of various feature conforming to the various matrices and tools used while applying ML techniques. Future scope in future, we can enhance the review process by doing empirical analysis of multimodal heart disease prediction techniques. These are the references that were taken in my research. And thank you.
Hello, Pawan.
Yes, ma'am.
Okay. How you have been motivated for this topic?
Ma'am, actually, I was interested in ma'am these health related issue. So that's why.
In the future scope, you mentioned empirical analysis. Any
Yes,
kind
ma'am.
of other analysis that you know and why you are going for empirical analysis?
Ma'am, we can apply another techniques like deep learning or other techniques further for improvement of
Yeah, then why you have chosen empirical?
empirical. Because ma'am, it gives better result.
Okay, okay, thank you.
Thank you so much, Pawan, for a nice presentation. And now I would like to call our next presenter, Akshita. I think Akshita is absent, so we can call our next presenter, Priyanka Jain, to present her paper on sequence-to-sequence video captioning system.
Hello,
Hello.
am I audible?
Yes.
Okay, I'll just share the presentation. Is the screen visible?
Yes, it's visible.
Good afternoon, everyone. I, Priyanka Jain, along with Parth Langalia and Dr. Zankhna H. Shah, are here to present our project titled Sequence-to-Sequence Video Captioning System. The main agenda of this project is to build a system wherein a user can upload a video and captioning of the video takes place. The various applications of this project include automatic surveillance of industrial plants for safety measures, and for to increase the experience of human interaction, it provides good clustering of videos based on content and better video searching experiences on website. We know that today videos have become an important mode of communication, and therefore its production is increasing day by day. The task has been made easier. The task of captioning has been made easier with the recent advancements in machine learning and deep learning. Better search algorithms and recommendation systems can be built using this system. The approach we followed has a great efficiency, and the generated description will have an open word vocabulary. Hence, for training the model, we followed encoder-decoder architecture. There are three elements in this architecture, that is encoder, encoder vector, and decoder. Once all the frames and features are read by encoder and encoder vector, the decoder generates a meaningful sentence word by word. LSTM is used for both encoder and decoder. So this is the basic system workflow of our project. So here we can see that the system starts when the user inputs a video on the website. The next task is the video pre-processing. Here conversion of frames takes place, which we will discuss in detail further. Then the next step is feature extraction. The frames that is generated from the previous step are passed through a VGG16 model, which is a pre-trained CNN model. And then the encoder decoder architecture that we talked about is used for the caption generation process. The data set. We have used MSVD dataset that is provided by Microsoft. This data contains 1450 short YouTube clips that has been manually labeled for training, and 100 videos have been given for testing purposes. Each video has been given a unique ID, and each ID has about 15 to 20 captions that have been labeled. The next we will discuss the modules in detail. So this is the basic 4 modules which have been carried out throughout the project. The first one from that is feature extraction. A video can be thought of a sequence of images. The important features from these images can be extracted using a CNN pre-trained on specific classification problems. The first step in the feature extraction process would be video pre-processing. In this step, images in the form of frames will be extracted from the video. Since there is a variance in the length of all videos, the number of frames extracted will also be different. In that case, to simplify the process, each video is divided into only 80 frames. After that, each frame is passed through a pre-trained CNN model, which is VGG16, and from each frame, 4096 features will be extracted. The frames, along with its respective features, are then stored in a NumPy array whose dimensions are 80 × 4096. So basically, there are 6 steps involved in the process, starting from loading the model, pre-processing the video by generating frames from it, loading of all the images before passing through the CNN model for feature extraction process, and finally saving features into a NumPy array. So here we will discuss the architecture of VGG16. It is a pre-trained convolutional neural network model, and it is considered to be the best vision model architecture till date. The 16 in its title refers to the 16 convolutional layers that have different weights. The most unique thing about the VGG16 is that instead of having a large number of hyperparameters, they focused on having convolutional layers of 3 × 3 filter size and max pool layer of 2 × 2 filter. In the end, it has 2 fully connected layers followed by a softmax for output. The max pool layer here selects the maximum element from the region of feature map covered by the filter. The output after max pooling layer would be a feature map containing the most prominent features of the previous feature map. The next module which we will discuss is cleaning and pre-processing of the captions. The text processing we have done is adding BOS and EOS tags before and after each caption respectively. The BOS represents beginning of sentence and EOS represents end of sentence. Hence, the model knows when and where to stop the prediction of the captions. So this is the basic example of the video of the text processing that was carried out for the videos for the data set. The diagram shows the final caption of a particular ID after pre-processing. The BOS and EOS tokens have been added before and after each caption. And we can also see that the captions have words less than 6. The captions do not have words less than 6 or greater than 10. The rest ones that do not, the rest of the captions which do not lie in this range were discarded. This was necessary because in the data set, the caption with largest number of words was 39, but for most of the captions, the number of words lied between 6 to 10. So if we do not filter out some captions, we will have to pad them all to the maximum length of the captions, which is 39. Since padding basically means adding white spaces, so most of the sentences predicted by the model will just contain more blank spaces than actual words, which would lead to incomplete sentences generation. The next module is training the model. As previously discussed, that there are two approaches possible. The first one is RNN and the second is LSTM. In our case, we decided to go forward with LSTM. The main reason for this choice was that RNN was not able to connect the information was from previous video frames to the present frame. Though it is a fact that RNN can learn to use the past information, but in this particular project, the gap between the relevant information and the place that it's needed is very high, and therefore LSTM was much more feasible to use. LSTM is a special kind of RNN designed especially to avoid the long-term dependency. The LSTM is easily able to remember information for long periods of time, which is very beneficial for our project. The cell state present in LSTM acts like a conveyor belt, and it makes the flow of information along the architecture very easier, and also the information remains unchanged. Here is the encoder decoder architecture that we have used. So now the output of 80x4096 will be the first layer of LSTM encoder as input, and the final output layer of encoder will be the input of the decoder. And accordingly, the captions will be generated as shown in the figure. There are 150 epochs and around 45 steps per epoch, but we kept early stoppage of 0.001, and hence our model was trained in 83 epochs. Next.
Dear presenter, you have last 2 minutes.
Yes, ma'am. Next, for searching the words from the vocabulary for generating the caption, we have two algorithms, greedy search and the beam search algorithm. Greedy search selects the most likely word at each step in the output sequence, whereas beam search algorithm selects multiple alternatives for an input sequence at each type step based on conditional probability. Since we can see that the performance of greedy search was much better in respect to time taken and caption generated, we decided to move forward with greedy search algorithm. So this is the implementation part. We developed a simple GUI, and wherein when we click on the choose file button, the video will be uploaded, and the caption, and after clicking on the submit button, the captions will be generated as shown in this figure. Yes, thank you.
Hello.
Yes, ma'am.
Priyanka.
Yes, ma'am.
Captions will be displayed or on the video?
Yes, ma'am. See in this figure, we can see that after uploading, the video is also played and the captions are also displayed below it.
And every time you are displaying only English comments?
Yes, ma'am.
So do you have any further, you can say, improvement or I'll say addition in your project or paper that it will display the comments in any regional language?
Yes, ma'am, definitely we can move forward with it. It will just require addition of new vocabulary and certain changes in the inference model.
So that is what next question is, what changes will be required if I want to be the captions in any Indian language, maybe Marathi, Gujarati, any other regional language. So where exactly the change will be required?
Ma'am, I think the major change first will be made in the data set. And then once we have all the data, all the words in different regional language, once the vocabulary has been expanded, we can work upon it.
Okay, thank you. Thank you.
Thank you so much, Priyanka. Now moving ahead, I would like to call our next presenter, Sarvesh, to present his paper on hand gesture controlling simulated mouse using computer vision.
My voice is audible, ma'am?
Yes, you're audible.
Is my screen is visible, ma'am?
Yes, it's visible.
Good afternoon, all. I am Sarvesh Jitendra Wagmare, third year student from Pimpri Chinchwad College of Engineering, Pune. My paper title is Hand Gesture Controlled Simulated Mouse Using Computer Vision, paper ID 24. And I had done research and wrote paper under the guidance of Professor Anand Birasta, sir. Here are the contents of this presentation. The big goal of this paper is to move the cursor with a hand using gestures and webcam. Um, for the introduction, every day in our life, we often use our hand to node and to do conversations. So by thinking of this, I had started to research and communicate with research to how we can communicate with the computer with the hand gestures. This type of interaction with computer could create revolution by not using complicated hardware. By using this technology in future, many individual can communicate and handle computer more easily by virtually displaying his or her hand to navigate throughout the screen, and this able to move the cursor and control the system. This paper is depend upon the color detection and vision based operations. The main motivation of this paper is we can ensure the hygiene issues using wireless human movements applications like this while using public computers. This mode of interaction with machines is more natural um, and can reduce the complexity of the operations. The machine can be controlled remotely from the distance. Um, for the literature summary, I had gone through some of the literature reviews and uh, I, I had concluded that there are two main ways to achieve this problem statement. One is computer vision and second is motion sensor. Each methods had its advantages and disadvantages. Let's talk about it. The problem with motion sensor is we have to define the gestures with the model, and it is very challenging to define a particular gestures to its distinct model. It is and while performing the gestures, it can overlap with the another gestures, and it will reduce the overall efficiency of the model. On the other side, the challenge of the computer vision is the camera module is a primary input device in computer vision. So the light intensity and visibility matters a lot in the computer vision. The another important point is computer vision. The position of the hand, it should be in an action area, which is the range. So in this case, I am using the computer vision because it is less expensive and than the motion sensors, and it is simple to put the whole thing together by using OpenCV and MediaPipe and NumPy libraries of the Python a framework. MediaPipe, this framework is used to detect face detection, hand tracking, and OpenCV. This library of Python is used to image processing and video capturing. Also, the NumPy library also is used in this paper, which is used to do numerical calculations. As per the existing work, as previous studies, many of them are assigning cursor pointer as a palm centroid. So, and fingers are assigned as a commands for that cursor, that is right click and left click. So the main drawback of the system is if any program is top of the screen, like any PPT or any PDF is on top of the screen, then like mouse is a mapped system, but hand gestures or computer vision is not mapped system. So you can move the cursor, but your fingers are above the action areas because the program or we can say the PPT is on the top of the screen. So you can move the cursor, but you can't command any right click or left click to that. So I proposed that as per the drawback, I will assign the cursor pointer to the hand's topmost part, that is the middle finger's top part, and assign middle finger as a right click and forefinger as a left click. Um as a multiple identification, because hand has a skin color, so it will very difficult to the system to recognize which is the pointer of the cursor. So here I uh, use red and blue color caps for identification of right click and left click. You can see the picture where I used color caps to assign right click and left click. So steps to achieve this project, we have several steps like video acquisition, color conversion, noise reduction, and cursor mapping. In further, in flowchart, I will define all the steps. If you see in video acquisition, the webcam, start the webcam. Real-time video acquisition. In this phase, the webcam is used to capture the actual time video at constant frame rate and resolution. After that, snapshots are extracted frame by frame using RGB shade layout of a matrix in which every detail includes a matrix of red, green, and blue. Hence, this is the main reason to choose the color cap are red and blue. Second is flipping of the video. Image of the hand moves towards opposite direction to the movement of the hand. In case hand moves right, then on screen it moves left. Hence, flipping is needed. Second step is color conversion, in which extraction of the red and blue color, HSV image generation and gray image generation is there. So why color conversion is needed? It needed to extract, subtract the extra fingers that are not assigned the commands and noise, skin color, background. To subtract these all the things, we have to convert RGB color format to HSV and HSV color format to grayscale. So the third step is noise reduction. There are filtration and removal of small objects. These steps are there. So noise is very important and crucial factor in any computer vision system, and that need to be satisfied because dust or other issues may occur. Little undesirable errors. Output also can compromise with the noise. Example, we can filter the noise by using median filtering of OpenCV. It finds median of the all pixels below the kernel window and uses that value to replace the middle pixel. So we can remove all the unwanted objects from the images. So lastly, the cursor mapping. Here now image processing is done and we can do mapping of the cursor using NumPy. In this calculation, executed on the concept of the major axis length of the red part of finger is there. So right click operation is we can perform by using this. Based on the mother image that we clicked earlier, we got information about the middle finger's major length. And by folding the middle finger, it defines threshold changes. Hence, right click will perform. Also, like right click, we can perform the left click operations. Uh, in this picture, you can see the center of the red region is calculated, and um, as now we can use centroid as a cursor pointer, but I am using cursor pointer as a red region topmost position because for the best performance and any case if cursor pointer is out of the action area, then output can be manipulated. Hence, I am using only the top position of the red part. Outputs and the further developments. as we can assign many gestures to the database, and doing that gesture operation can be performed any operations like right click, left click, pause and play the video, uh, page up and down, dragging or dropping, page shifting. We can do this. We can use for the further developments, we can use newly introduced 21 landmark media pipe library, in which hand is divided in 21 landmarks.
Dear
And
presenter, please conclude your presentation.
okay ma'am, okay. So for the conclusion, the goal of this paper was to create a system that could collect images and perform mouse function or cursor functions, such as moving the cursor pointer, dragging and clicking by colored caps on the fingers. The OpenCV MediaPipe and NumPy is used to create this system. Since vision-based technology is far less expensive than contact technology, it's easy to maintain because there is no wear and tear and cost effective. So these are the applications of this paper. These are my references. Thank you.
Okay, Sarvesh,
Yes, ma'am.
what is the accuracy?
Ma'am, I didn't check accuracy because this is the theoretical paper.
Okay, it is not yet implemented.
No, ma'am. It's my final year project, so I need to do this.
Okay, okay, thank you, thank you.
Thank you, ma'am.
Now we can call our next presenter, Archit Tiwari, to present his paper on e-commerce web portal using full stack open source technologies. I think Archit is not here, so we can move ahead. We can call our next presenter. Siddharth, to present the paper on blockchain driving smart healthcare system challenges, technologies, and future research.
I hope my screen is visible and I am audible.
Yes.
Good afternoon, everyone. I am Siddhant Thaplia, student of Master of Technology Computer Science stream from Graphicara University, Dehradun. My topic of research is Smart Healthcare Challenges, Technology and Future Research, a survey. It is totally a blockchain-driven smart healthcare survey, which I have done in the guidance of Dr. Mohammad Wajid and Dr. DP Singh. First of all, the contributions that I have made in the paper is we have discussed some issues and challenges of smart healthcare system. Then we have provided the details of network model of the smart healthcare communication environment. And then we have provided details of various tools and technologies of the smart healthcare system. Finally, we have finished with some concluding remarks and future research direction in this paper. First of all, the overview of the paper. First of all, I will discuss the introduction, then pillars of healthcare, need of technology in healthcare, popular healthcare technologies, challenges and issues that I have find out in the various papers and technology, then future research directions, and then some of references from where I have took these details. First of all, what is smart healthcare? Smart healthcare consists of IoT nodes, such as various sensors for if we are taking a scenario of hospital, it might be a sensor for checking the blood pressure level of a particular patient or heartbeat ratio or oxygen level of a patient. These might be IoT nodes. Then cloud server, all the sensors which are detecting that data should store that data in the cloud server. So we will maintain a cloud server for storing that those data. Then we have real-time monitoring system for that because we are implementing sensors, so we need a real-time monitoring system so that we can check the real-time checks of the patient. Then some artificial based mechanism so that we can analyze that data whether this heartbeat ratio is normal or there is some emergency for the patient, like that. Then we have some machine learning trained models for analyzing that data and giving some prediction, like if suppose a patient comes to the hospital, whether he has a pneumonia or not, but a doctor is not physically present at that time, we can check the X-ray report of the that patient, and we can analyze the whether that patient has a pneumonia or not by the help of various machine learning techniques. First of all, there are four pillars of healthcare sector. First is patient-oriented design. Always, whenever we will design a healthcare sector, it should be oriented to the patient, because our beneficiary is the patient, so that we can give the proper services to the patient. Then we should have the accurate analysis, because in the healthcare system or the healthcare sector, any small mistake can cause a blunder. Any modification in the reports or any modification in the sensor data can give us a blunder. So it should be the accurate analysis for all the data. Then data should be processed effectively, because we are having various nodes from where the data is coming from. So we need a proper processing of data, so that our integrity of the data and confidentiality of the data should be maintained. Then management of data, because we require we are having a huge amount of data, we should have a particular server or database management system, so that we can manage our data properly. Then there is why we need the technology in the healthcare system. First of all, we need some real-time monitoring, because in the offline mode we cannot check real-time monitoring of the patient all the time 24/7. But in case of technology, we can do so. Then easy access to the facilities, because we are in India or everywhere in the world, we are having various areas which are very much far flung areas, where we cannot give all the necessary services. So in that case, we can implement our technologies so that they can access our facilities, like metropolitan cities are accessing. Then to improve efficiency, because in offline mode we are not that much effective in terms of accuracy. So for the accuracy, we need some technologies like machine learning tools, artificial intelligence tools, so that we can improve our efficiency. And our time optimization must be a factor for that. Then for more accurate and quick analysis, by the help of various technologies, we can do a more accurate and quick analysis. Similarly, we can have a time management in this reason also. Then finding correlations between similar diseases, because we are having various diseases in the world, but most of the diseases are having a similar symptoms. So for detecting those correlations, we can check the diseases by the help of these technologies. Then providing access of healthcare services in remote area, as I have already discussed, we can implement those technologies in far flung areas also. For the proper management of data, because in offline mode we are storing data in the form of pen and paper, but in case of technology, we are storing our data in a database or in cloud, so that our proper management of data and proper access of data can be done. Then knowledge sharing, because we are storing our data in the cloud server, we can use that data for further exploration or further machine learning algorithm, so that our knowledge should be shared with the all beneficiaries. Then there are some popular healthcare technologies like 3D printing, artificial organs, robotic operations, health equipments, virtual reality, and telehealth. In 3D printing, we can print, like if someone got his hand fractured. In that case, we can make a 3D plaster for that. Artificial intelligence, we can make a artificial foot or artificial hand. Robotic operation, if we have a absence of a doctor, we can perform some robotic operations on the patient. Like where there are various health equipments we can use for the new trending healthcare technologies. Then virtual reality, in virtual reality, we can operate a particular patient without having a physical presence of the doctor at that end. And telehealth, by the help of various communication mediums like mobile phones, email, or other things, or video conferencing, we can do the achieve the telehealth in the healthcare technologies. Then what are the challenges and issues in this in these technologies. First of all, information security related issues, because when we were storing our data in the offline mode, we were having it on the pen and paper format. But in case of technology, we will store that data in server. So there might be a security breach in that case, because as we all know, our healthcare data is very much vulnerable to the security, so that our data should be secured. But in case of technology, there might be some challenges to storing that data. If we are not using a authentic server or authentic database, it might be a challenge for us. Then correctness of the system, because we are storing our data, because we are taking our data from sensor, there might be some errors in the sensor which can give give us a wrong input or wrong output, which can cause the error in future. Then interoperability, because every sensor or every machine is not compatible on every sector, so that it should be a challenge for us. Then obsolescence of the tools and technologies, because we are having there are various updates in the tools and technologies on the very frequent basis, so this might be a challenge for us. Then there are some information security related issues, like I will elaborate this. Like, we require proper authentication and access control mechanism. Any error or data manipulation can cause blunder, because it is a healthcare server, so we require a proper management. Frequent security checks are required for overcoming these related issues. Then I have discussed correctness of issues. Our data should be correct and error rate should be negligible. Then interoperability, as it consists of various technologies, this complex structure requires more efforts to maintain interoperability, and we require more technical support for maintaining this type of healthcare sector. As well as the frequent updates are required for maintaining that technology. Then the tools and technology for effective working, new
Dear
technologies
presenter,
should.
you have last 2
Yes,
minutes.
ma'am. Yes, ma'am. Sure. Then the future research direction, I have first future research direction is secrecy of healthcare data. Our data should have maintained the secrecy, like use of authentication and access control techniques. Another is compatibility of different tools and technologies. We should use the technology which are compatible with the global level. Then there are some limitations of technologies. Administrators should aware of pros and cons of the technologies. Without that, we cannot implement any technologies, and proper wiring and environment setup should be established. Then we should know the accuracy of the system. There should be negligible error possibility. Then there are some references that I have taken for my research. That's all, and thank you.
Okay, Siddhant.
Yes, ma'am.
Yeah. Which type of database is used by blockchain?
Ma'am, in blockchain, we are using a database which are like we are creating a blocks for storing our data, so that it is similar to the linked list of the data structure. All the nodes are connected to another.
No,
With
I mean to say, is it centralized, decentralized?
ma'am, decentralized.
Whether it is decentralized, whether it's traditional or it is distributed.
Ma'am, it is a decentralized and distributed, because we cannot go from one node to another node without having the address or access of that node.
Since do you know this, that blockchain is using distributed database, can we perform all the crude operations like traditional database on blockchain?
Yes, ma'am, we can perform, because traditional methods are much more easier than implement to the actual which we are using in current scenario. I have already implemented these techniques, those future commitment, those I have discussed in IEEE General and MDBI General. I have already published my papers.
Okay, and there are three types of blockchains. Which one you are going to use? You have used in your implementation?
Ma'am, in the implementation part, I have first I have only implemented the scenario without the blockchain.
Okay, okay. Thank
Yes,
you.
ma'am. Thank you.
Now we can call our next presenter to present his paper on leveraging blockchain concept, service delivery, acceleration in a post-pandemic time. Praful.
Hello, can you hear me? Hello.
Hello.
Am I audible?
Yes.
Hello, can you hear me?
Hello.
Yeah. Okay, good. Hello.
Yes, sir, you are audible. So please start your presentation.
Am I audible? Okay. Yeah, great. Good afternoon, everyone. It's a pleasure to be part of this forum. I'm presenting to accelerate service delivery post.
Hello. Dear presenter, we are not audible and your voice is break. We can wait few seconds. Otherwise, we can move forward to our next presentations. Praful, are you facing some technical issue?
Yeah, I'm back. Am I audible now?
Yes, you are audible.
Just a minute. I'll reshare my screen and start it. Okay, is my screen visible now?
Yes, your screen is visible.
Yeah, to set the context, I'll just pick up from where I left. To set the context before us, like what we are doing here is evolving avenues for authentic transactions with minimal human interaction. And why we are doing it is we want to reduce the trips to the offices by the citizens in the post-pandemic times. And how we are doing it is to leverage the technology options for information linkages and reuse it using the blockchain concept. It's just a concept. It's not an end-to-end blockchain approach, but what a service is all about. If we are using services every day where we have a application which is submitted with certain sets of information, and these are validated, and on approval the service is actually granted. So these are the 4 basic steps for any service which is delivered. And at the background of this, if we see, the set of information is nothing but an information is coming from some other source which is validated. So basically it's a chain of information links which is forming a data chain in a transaction. And what it is basically, if we relate with a conventional chain, if any one link fails, the whole system comes down. So it is nothing but here a transaction fails if one of the information sets is not validated correctly. So this concept is looked into from the technological standpoint that in a service, what is a core process and what is a complementary process which is supporting a particular transaction. Now, just to drill down further, what are the current issues in the service delivery processes? Like we have multiple touch points, like a citizen is required to have multiple authentication documents which he needs to carry from different sources. There is no information exchange among the 2 systems which are operating independently. Then digital information is not available with the provider ready-made for an authentication. Then multiple data validation checks are carried out during the service delivery. Then it leads to multiple citizen interactions and no information parameter linkage. So these are the issues which are there that is leading to multiple reworks. And I'm going to explain it with a concept of block, which is explained through an example of a registration process which is there. So an applicant goes to, say, for example, a register office to register a document for his property. So what happens is the following information sets are checked. One is the index ID of the property, which is issued by the corporation. Second is the record ID, which is issued by the city survey department. Third is the permit ID, which identifies the permit of the building which is getting transacted and its completion ID. And fourth is from the treasury point of view, whether the duties or stamp registration fees are paid or not. So these events are actually happening independently, and they are now the applicant carries these four things to the registrar office and gets his document registered. In addition to that, that property has a consumer ID, which all the utilities are provided at that particular place, which are identified by another identifier for the owner of the property. So what happens is these things are validated, and if these are up in order, then the transaction is either approved or rejected. So once the transaction is approved, there are downstream and again data updates. One is the new owner gets registered into all the utility connections. Then the new owner is given a sale record of the transaction we just carried out. Then his record is again updated into the city survey department. And then the new owner data is updated in the corporation. So we have a set of information which is pushed. First is validated from the before the approval, and post approval it is again pushed to the respective authorities for updation. But in today's time, what happens is the citizen goes 4 times to collect this information, and then again 4 times he goes back to update the records in the respective authorities. So in case this all the information forms a block and it is reused for updation of the system records electronically, then it becomes a seamless application, and it saves a lot of effort in terms of the individual. So now what happens is the information is basically linking the identity and the service provision conditions. Then one time it is updating all the records in the respective data sets. Then data is remaining with the parent authority, but it is linked to the service provider. Then the department validates the data digitally so that there is digitization cost is also reduced. Then there can be a scope for volunteering, because there's some agencies can work on those portal and assist the citizen for carrying out a transaction. And then this becomes a single sign-on which builds on existing applications of the departments and can be replicable across the cities. So what happens basically in terms of this automation, it reduces the trip length because it is available at the doorstep. Then all the digital validations are carried out, the payments are digital, and the service delivery is also digital document, so that all these trips are reduced. So from for a service, if one has to do 7 trips, now it is reduced to 1 or 2 trips. And then if you see the scalability of this, so in a city landscape, if you see the spread of the services, it can reduce to the trips to the extent of 25,000 trips per day if all the validations happen seamlessly at one place. So that is the catalytic effect. And then I also listed down the approach for its implementation, how this can be done. I'll not go into details of each of the activities. So it is a 4-stage implementation plan, and this is very easily doable through linking of the information from one service provider to the other. Now, what are the distinguishing factors? It is the simplified integration between one department and another department website and information. And the information exchange happens online real time, and the specific data to reduce the cycle time and the service fulfillment time. It becomes a virtual single window, eliminating the need to visit different offices. End user experience is also enhanced with the extended single sign-on. And ease of reference of similar cases is possible, because if the information is clubbed in a block, it can be referenced for next subsequent transaction for the same customer. So scalability part is also established here in this particular example which I gave. So basically it is forming a circle of trust between the information providers through information exchange. So this is nothing but leveraging the existing setup. It is a federated identity management solution which has to be built over existing databases. And it gives option for end user to upload the artifacts which are validated, saving the digitization cost. and information exchange post-validation accelerates the cycle time. So this is precisely what I had to present in the time allotted. And for any questions, these are my coordinates. I can be reached for any clarity either now or in the subsequent. Thank you.
Okay, Praful,
Yeah.
I must appreciate your presentation. It was very nicely organized and very well explained.
Thank you.
Yeah. My question is whether it is implemented.
It is implemented in not at the scale where I visualize it. Currently,
Okay.
in some cases, this is getting implemented. If, for example, in income tax services where identities are validated real time when you submit a return, then your return is also verified electronically through referencing the other databases. So basically, this is the same concept which is scaled up for a day-to-day service options. Then this will become more familiar for the citizen to actually avail that.
Okay. 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 Thank you. Thank you.
Thank you.
I would call our next presenter to present her paper on application of deep learning for COVID, Twitter's sentimental analysis toward mental depression.
Hello.
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 Yes, you are audible. Please start your presentation.
Is my screen visible?
Yes.
Hello, everyone. I'm Nasira Parvez. I'm a graduate student at University of Southern California, and I'm currently pursuing Masters of Computer Science here. Today, I'll be presenting application of deep learning for COVID sentiment analysis towards mental depression. The idea of the paper is 72. So our project, the research project that was done primarily focuses on identifying what effect COVID-19 had on the mental health of the people. The people were at home during COVID. They were confined to four walls, so their mental health was obviously affected. And for the same, we have used tweets that were made in the month of March 2020, when the pandemic was at the peak. In our methodology, we have used the following techniques. For the preprocessing of the data set, we have used the NLTK module in Python. The labeling of the data set has been done employing active learning. We have classified the tweets as depressed, non-depressed, and neutral using both XLNet and BiLSTM models. For comparing the metrics, we have used accuracy, F1 score, recall, and ROC curve. The project is aimed at using the tweets during lockdown as well as the post-lockdown and the post-vaccination tweets. The dataset that has been collected we have used two datasets. One is the publicly available tweet IDs from TweetSet. These were hydrated using an online hydrator, and the post-COVID data tweets have been collected from the Tweety library of the Python. During the pre-processing of the tweets, we have removed the columns that were other than the ID as well as the text, because the text consisted of the tweets that we used for classification. The retweets have been removed. The stop words like it, the, boy, girl has been removed. The tweets that were made in languages other than English have been removed, and the hyperlinks that were present in the tweets that have also been removed. The data, the tweet has been stemmed and lemmatized so that other verbs or nouns of the verb can be stemmed to a common word that becomes easy for classification. The labeling of the Twitter dataset has been done using the semi-supervised approach. In this, a part of the dataset was manually labeled by me and my teammate, and an SPC classifier was trained on this dataset. The feature selection was done using TF-IDF factorization, and the tweets were labeled as neutral, depressed, and non-depressed. The first model that was implemented was BiLSTM. BiLSTM is basically placing two LSTMs, one that works in the forward direction and the other that works in the backward direction. LSTM is a long short-term memory. It is a kind of RNN network, but they selectively remember the pattern using the forward case. For the BiLSTM, the embeddings that has been used by us is the global embedding and the embedding dimension 16. The model has successfully been implemented, and we achieved an accuracy of 82.33%. The next model that was implemented was the BERT model. We used a pre-trained BERT model and added a layer of classification on the top of that for classifying tweets as repressed, non-repressed, and neutral. In BERT, half of the model is half of our input is masked, and the model tries to predict the rest of the input on basis of that. Softmax activation function has been used for the same. And for classification, as I previously said, a classifier layer has been added on top of that. We have used an Adam W optimizer and the get linear scheduler. XLNet is an autoregressive generalized model. It is from the same library as BERT, that is a transformer library that works on activation mechanism, but an XLNet does not mask the input, so the input does not get corrupted in case of XLNet. For building our XLNet model, we use the XLNet tokenizer. Pre-trained XLNet model for sequence classification was fine-tuned for our purpose. Predicting a small data set for predicting post-vaccination tweets was collected. The BERT model achieved an accuracy of 96.7, and we used this model to predict the tweets of the post-vaccination. This was followed by comparisons of the neutral, depressed, and non-depressed tweets. These are the results. This is the word cloud of the pre-lockdown Twitter dataset. We can see words like alone, health, panic, pandemic present in these. This is the post-vaccination word cloud. We can see words like hope, happy, glad, COVID, sad. These are the results that were given by LSTM. As you can see, the accuracy of the model was 82.33. These are the BERT results having an accuracy of 96.7165. And the XLNet had an accuracy of 95.8. So these are the words that were found, common words during the pandemic, like pandemic, hope, COVID, anxiety, mental health, coronavirus. And these are the post-vaccination, the post-lockdown tweets: hope, support, happy, push, glad. Although we tried our best to make the project as much as we could, but we focused entirely on the English language. We know that the European countries do not use English language. They use their own languages, as well as in India, a lot of people speak in different cultural languages. So I think the Europe was a lot affected by the pandemic, and we could not focus on those three. So I think that is somewhere that we could work more upon. Thank you.
Hello.
Hi.
Hi. I have one suggestion, Nasila.
Sure.
If somebody put any emojis like happy face or sad face, or you can say thumb, in that case, will it work?
We have actually removed all the emojis, and in the pre-processing, they were removed.
Yeah, that is what I suggested, that if you can
Yes.
include all these also in your future work.
Definitely.
Yeah. Okay. Thank you. Thank you.
Thank you so much.
Now we can call our next presenter, Judy Chaudhary, to present her paper on qualitative analysis of SQL and NoSQL database with an emphasis on performance. I think she's not there. So we can call our next presenter, Piyush, to present his paper on malware family classification using music information retrieval techniques.
Yes, am I audible to everyone?
Yes.
Okay. I'm starting to share my screen. Just a second. Okay. So hi everyone, I'm Piyush Chandelia and I'm a final year student from Delhi Technological University. And I'm here to present my paper, which is titled Malware Family Classification Using Music Information Retrieval Techniques, which I have written along with my co-authors Navdeep Sehrawat and Prajwal Kumar under the guidance of Professor Rahul Gupta. So starting with why malware. So malware identification and eradication has become a significant task in system security because of the large number of dangerous programs which are released each year. So, and much research has previously been done and proposed on malware detection methods based on high-level data like opcodes, function calls, PE headers, or programs control flow graph. But because of new obfuscation techniques, extracting high-level features is inaccurate and time-consuming, whereas approaches which are based on program bytes are faster and more accurate. So the goal of this research work is to perform a byte level analysis for malware classification, which utilizes signals processed from audio files, and also propose a study which depicts the importance of different audio features in malware classification. So coming to the data set that we have used is a cleaner version of the data from the competition Microsoft Malware Classification Challenge, which is present on Kaggle. You can see the composition of the data set here. This data set contains malware files from 9 different families, and it contains a total of 10,868 malware samples with a size of more than 500 GBs. So starting with the methodology, our process contains 4 different steps. The first step is the conversion of the executable byte file to MIDI files, which is the blueprint of music. So, so we start the process by converting each byte into musical notes. Now, while doing that, we faced a problem that the MIDI signal notes range from 0 to 2 to the power 7 minus 1, which is 0 to 255. And every byte in the byte file can have 2 to the power 8 different values. So we can't exactly match each MIDI signal note to each byte file, right? So to solve this, we chose a strategy. We studied different strategies and chose a strategy in which every unique musical note is assigned to each bit if it is set, and no musical note is assigned to that bit if it is unset. So for every byte, each bit represents a musical note which is played on different channels at the same time, which also eradicates the chance of overlapping of notes, right? So as you can see, this is the algorithm that we developed, and for each bit of the byte, we change the channels and use different pitches or different musical notes to play our music, right? In addition to this, you can see that we have in line number 16, you can see that we have added a 1.25 second, right? So what we are doing right there is that between the notes of each successive bytes, we added an empty note of 0.25 seconds, which reduces the overlapping sounds caused by the echo from the sounds of successive bytes, right? So which in turn increases the accuracy of our overall process. Now, the second step is conversion of MIDI signals to WAV files. For this step, we used a synthesizer, and the synthesizer that we used was PyFluid Synth library for generating WAV files from our MIDI signals. Now, this step is the most time-consuming and the one with the greatest CPU and memory usage, right? So, moving on to the next and the most important part of our research, the next part is audio feature extraction. In this research, we studied 3 different audio features. The first one is Mel frequency cepstral coefficients, also which stands for MFCC, and MFCC's signal. It consists of a small number of features from 13 to 20 that define the spectral envelope's overall shape. Right. The next audio feature that we studied is Chromagram, and it contains chroma features which are based on the 12 different pitch classes. We have used 3 different type of chromograms: the Chroma STFT, which uses short-term Fourier transform, the Chroma Sense, which uses energy normalization, and the Chroma CQT, which uses constant Q transform. right? So the next audio feature is Mel Spectrogram. The Mel Spectrogram is created by passing raw audio waveforms through filter banks, and there are 128 filter banks and 128 timestamps per clip. So that is why a 128 cross 128 shaped feature vector is generated for each frame. All of these features are calculated frame by frame. So each feature, and each frame ranges from around 9 to 16 milliseconds. As a result, these features describe each signal frame individually. If you notice, a 5-minute long music generates about 5,000 frames, and the size of the feature vector then becomes very large and unmanageable. To overcome this, we downsampled our feature using mean, covariance, and standard deviation of the data, right? But with all of these features, we also divided the malware samples into smaller parts to get localized variations in the features, which improves our accuracy of the result, right? So for example, in MFCC, we divided the sample into 18 parts, the malware sample into 18 parts, which generates for each part 13 MFCC features. So in turn, a 13 cross 3, which is 234 features, were generated for a single malware file. So we downsampled it and we divided the malware file into different parts so that we could get localized variations, which could improve our accuracy. Now the next step is building the model, right? And the next step is building the model, and after the audio features are extracted, we use these audio features and classify our malware samples into different malware families. Right now we have studied this approach and various musical features on a few classification algorithms, which include some simple classifiers like KNN, SVM, and logistic regressions, and some ensemble classifiers also, such as random forest, XGBoost, and neural networks, right? So coming to the results, in this examination, the impact of each feature is studied along with various combination of features on different classifiers, right? Now, if you can see the table number 1, this represents the accuracy of different classifiers with features taken one at a time. And it can clearly be seen that MFCC is the audio feature which gave the best accuracy of 96.91% with random forest algorithm. Now, the table number 2, it represents the performance of features when taken in various combination and with various classifiers. It can be seen that every classifier perform better when features are taken in combination, right? And we can see that the best accuracy of 97.12% is achieved on random forest classifier with a combination of MFCC, Chromagram, STFT, and Mel Spectrogram. Now, why did it perform better? Because why did it perform better is because MFCC defines the music through spectral envelope. The chromagram represents through harmonic and melodic characteristics, and Mel Spectrogram utilizes the sound information from to our model. So all of these different features, they provide more relevant parameters to define the music when these features are combined. So we get a better accuracy. Now, if we see table number 3, it is a comparison of the results from previous approaches. And our approach gave an accuracy of 97.12 when we perform music feature analysis and used random forest, right? If you see the 2018 paper of Farooq Manish, music classification using random forest, they had an accuracy of 95.87%, and we've improved upon that by 2.1, by about 2%, right? And these are the different ways of doing malware classification, which involved image conversion and PCA transformation, the GIST SVM, and the MALDEEP approach. So to conclude, in this work, we have researched and employed music classification techniques to classify malware files into different families. The proposed study showcases the importance of the different audio features in the classification of malware samples over the different classifiers employed, right? So we look at the different combinations as well as individual features. Now, in future, we are looking to explore into some evolutionary classifiers, and we'll try to test our study and these classifiers on other data sets as well. The other data set that we have in mind is the Android malware dataset and the MalMS dataset. In addition, we'll also try to study other musical features and include them in our study, which are spectral centroid, bandwidth spectral roll-off, and zero crossing rate. So to see if by including them, we can see any improvement in the accuracy of the classifications. So that is it about the research. Thank you.
Hello, Piyush. Can you
Hi.
go to that slide, last table of results?
Yeah, just a second. Yeah.
Yeah, here I just have one question.
Mhm.
The same approach that has been used by you.
This one, right? Music classification
Yes,
using
yeah,
random forest.
random
So we
forest.
have improved upon this by
Yeah,
three
just I
things.
wanted to know
Huh.
what extra thing or what you have done different so that you are getting better accuracy.
Yeah.
And the second question is, but if you compare this one FPR, that is very less or negligible as compared to the paper which has been implemented in 2018. Why is it so?
Okay. So to answer your questions, to answer your first question, we have employed our own algorithm for converting executable byte files into MIDI files, right? And the additions such as the reduction of echoes increases our accuracy, right? So we have done these steps, and we have studied this approach of building the MIDI files that increases our accuracy. The second thing that we have done is actually this thing where we provide localized variations. So in their approach,
So
what they did
what
was
you
they,
mean to say is that what the methodology which you have used is totally different.
yeah. So the method, so this step is different from their research, and from their research, they have only used MFCC and Chromagram, but we have employed a combination of these three, right? And the combination of these three provides a better variation to the feature, and it provides a better accuracy. Also, along with this, we have divided our malware file into different parts, which includes localized variations in the feature vector, which also helps us to improve our accuracy, actually.
Okay, and what about FPR?
So the FPR is different because they both use different data sets, actually. So the data set that we have used is actually Microsoft Malware Classification Challenge dataset, and the dataset that they have used was actually the MalMS dataset. So because they are on different datasets, they have a different FPR.
No, then you have to compare the result with the same data set. You have to use the same data set, and you should compare all these 4 parameters.
Yeah. So that is why we have written in future work that we
Okay,
will.
thank you.
Yeah. Thank you. Thank you.
Thank you, Piyush. And now we have one more presentation in this session. So Judy Chaudhary to present her paper on qualitative analysis of SQL and NoSQL database with an emphasis on performance.
Good afternoon, everyone. This is Judy Chaudhary. I'm here to present my paper with title Qualitative Analysis of SQL and NoSQL Database with an emphasis on performance. The co-authors.
Dear presenter, your slide is not from the beginning.
This is from the beginning, ma'am. This is the first page.
But it's seeing a conclusion and future scope.
Okay, just give me just a second. Let me make it from the first.
Yes, it's perfect.
Yeah, it's well now.
Yes, done.
Yeah, my paper ID is 90, and let's start with the work. First is index work. What we are going to read today about my paper, it's abstract introduction, literature review. What are NoSQL databases? How we compare them with relational databases? What is the qualitative comparison we have provided with this paper? Conclusion and future scope with the references. So the abstract says there are a number of social websites which are generating very large amount of data which is unstructured in nature, Actually, this makes data to actually manage data in relational database management system to handle such kind of data. That's why SQL databases proved them inadequate, and NoSQL databases coined up after the concept of SQL facing such an issue. And these NoSQL databases have higher performance. They provide better scalability to how these NoSQL databases provide better scalability. Let's discuss with this paper. Actually, this paper stratifies NoSQL databases performance on the basis of CRUD operation, which we have brought with this. So the introduction says, in the past few years, the number of applications often used SQL databases, which are
Sorry
like,
to interrupt, your
yeah,
presentation is not moving.
my presentation is not moving. Actually, I'm continuously changing the slides.
No, you are from first slide.
I don't know why this is happening. Is it okay now?
Yeah, is it done?
So this interface is quite fine with if I'm presenting my work with this interface. If I'm not sharing it from the on the whole screen, is it okay now?
This is the still introduction slide.
But is it moving right now?
Yeah, now it
is
is moving. Now it is moving.
Okay, fine.
Yeah.
So we were on the introduction part. Actually, what I was telling you about my introduction is, from past few years, number of applications are frequently using SQL databases to collect data. Earlier, what happened? The database earlier database actually format the data in tabular format, which makes it easier to understand. But when it comes to manage unstructured data can consist of images, text, audio, video, anything like that. So SQL databases were not able to handle such kind of data. That's why we came with NoSQL databases. And NoSQL databases provide such facilities like flexibility, scalability, performance, availability. We will discuss about these features in my next work. What literature review says, these are few authors which has presented their work respected to my work also, which is related to my work as well. Their purpose was to understand the comparison between SQL and NoSQL database, as I want to extract which database is better to opt for massive amount of data. So let us start. These are all the literature review part, and this is the NoSQL databases from where I have started my work. NoSQL databases are just an alternative to SQL databases, so that we don't have to worry about tabular format or something like that. We have to mention data in rows or column manner. So we just opt NoSQL databases because they are not, they do not follow predefined schema. It even provides us few approaches like key value NoSQL database, document based NoSQL database, column based NoSQL database, graph based. These all have different properties which you can choose according to the use you want for your database. Next is, this is a work we have taken from previous papers to just extract what we can go with our future work. This is feature comparison. What makes it more suitable, why we are choosing NoSQL database here is, it's the flexibility of NoSQL database, because they do not opt pre-defined schema. They can go with a dynamic schema, which means data, you can save any kind of data at any time. Next is scalability. Like SQL databases usually supports vertical scalability, which risk hardware failure. Whenever we need to upgrade the database with massive amount of data, scalability becomes expensive here, because we have to incorporate with more number of hardwares, whereas NoSQL provides horizontal scalability. That means whenever the amount of data grows, data volume will also grow. It can even resolve by adding additional nodes like processing power, such as adding servers. If we can add servers to it, it will minimize the expense. Next is availability. Availability refers to, like, if we have stored some kind of data and due to some failure we lost that data, but NoSQL database provide you with a feature like you can extract data from any other node because it is stored at multiple nodes. It is connected to multiple servers. So it resolves failure and provides you with the data. Next is performance. Relational databases lack with this point as well because the information comes from non-volatile memory when we talk about SQL databases, and when we talk about NoSQL databases, it takes out the data from volatile memory, which is fast at processing. This is the work we have done. We have used Likert scale here with the studies mentioned in this slide. We have taken few studies, past studies, and we have used Likert scale to compare SQL and NoSQL database so that one can choose the best suited database according to their requirements. And the aim of this study is to highlight the performing databases for large volume of data in order to CRUD operation, which means create, read, update, and delete operations. This is the first table. We have created this with the help of Likert scale. The lowest one is rated as 1 and the highest is rated with 5. Criteria covered here is mentioned with the table: performance, scalability, flexibility, and complexity, which we have read earlier. And the second column we have taken is for CRUD operation, like create, read, write, and delete operations. So next tabular format where we have compared the data, both kind of databases, is on the basis of their performance, scalability, flexibility, complexity. Table 1 shows what are the values corresponding to every parameter, and table 2 shows what we have created with the help of Likert scale. Table 3 summarizes the performance of CRUD operation, which we have studied in earlier slide. Here in this slide, we have worked with create, read, and delete operation. We have mentioned this in table number 3. This is the graph we have analyzed after making these graphs. After making these tables, we have generated these graphs, which shows NoSQL databases performs higher than SQL database in every aspect we have read before. So we have concluded that NoSQL databases provide higher availability of data with higher scalability, and SQL databases, as SQL databases provide tabular structure to store information, it makes it harder to opt for current data generated because nowadays industries generate unstructured and semi-structured data, which needs flexibility in schema actually. So this study concludes NoSQL database are more efficient to use if it's about semi-structured or unstructured data, and if it's about structured data, you can go with SQL databases as well. And to have flexible data model for scalability purpose to enhance efficiency. So NoSQL databases have their own property like scalability purpose. You can enhance your performance due to their scalability factor, due to their flexible nature, due to their availability feature, and their performance we have seen in CRUD operation as well. So the future scope says that our further study is to implement NoSQL database on massive amount of data so that we can prove the efficiency of NoSQL databases. And here are the references. And here are the references we have taken in our research paper. And that's all about my presentation. Thank you.
Yeah, Jyoti.
Yes, ma'am.
On how many databases you have checked this?
Ma'am, this is the earlier studies we have taken, and the data has been used. There is more than 50,000 data sets. And now in our upcoming future scope that I have considered, like I will implement this, it will be more than 50,000 data sets.
50,000
records.
50,
Yeah, it's records.
Sets.
No, 50,000 records.
Records. Yeah,
yeah.
I'm asking you how many databases?
Databases are actually, here are 5 databases we have considered: MySQL, Oracle, MongoDB, Cassandra, and Redis. In figure 2, you can see here we have used 5 databases, where Oracle and MySQL are SQL kind of databases, and other 3 are NoSQL databases.
What is the size of each database?
May I know the perspective you are asking this question? The size of each database
What
means
is
the
the
number of
size
records.
of, yeah, maybe in terms of number of records, or maybe in the size of MB or KB,
No, I
size of
can tell you
database.
in terms of records. The study has been taken with very small data records. It was taken first with 100 records. After that, we have observed with 500 records. After that, it has taken with 10,000 records, and then after 50,000 records. After that, we have analyzed the results and we created this graph.
So is the size matters?
Yeah, obviously size matters. If number of size, if the data size is smaller, you can even go with the SQL database. It will give you efficient working. But when it comes to a massive amount of data, and as well as semi-structured format, like if we include images, documents, PDFs with the current data, you can go with NoSQL database. They will give you more efficiency there, irrespective of SQL databases.
Okay, okay, thank you.
Thank you, ma'am.
Thank you so much. And we had completed all our presentations, and I sincerely thank our authors and all participants for being a part of this international conference and for the excellent presentations. And thank you so much. And now I would like to thank our session chair to chairing this session. Thank you so much, ma'am, for your valuable time and your presence.
Yes, Richa, thank you very much for inviting me to session chair on this sunny Saturday afternoon. I really enjoyed the afternoon and was amazed at the amount and quality of work the participants had put into their papers, and professionalism of their approach as well as presentations. So everyone who took part has much to be proud of, and I wish all the best to all the participants. Thank you. Thank you.
And ma'am, it's a token of appreciation on behalf of Global Knowledge Research Foundation.
Yeah, thank you so much.
And I have one more request to everyone. Please kindly turn on their cameras for a quick snapshot for making this conference more memorable. Thank you so much, everyone. Thank you so much, ma'am.
Thank you. Thank you.